Welcome to this anticipatory video of our main video on Christian cosmology, which you will find a link to in the video description. This video is merely intended to provide students a background understanding of how the night sky works and how they are oriented in it when they look up at it. So after you get the gist of this video, then please go on and watch the next one down in the video description. Prior to learning the constellations, we have to make sure that you understand how the heavens work and where your place is in it, and therefore how they appear to you based on where you are. So the night sky looks like this. The north and south poles are like that, and I'm just displaying east and west here schematically. Obviously the whole sky would go around you, but I'm just compacting it onto a flat surface here on the screen. So you can imagine that east and west would join somewhere behind you. Okay, the celestial equator is where Earth's equator would be if it were marking a line across the sky. But our field of view is very limited. We only get to see maybe 1/6 of all the stars at any given time. Why is that? Well, it's because you can't see stars on the other side of the world. So if you are living where the yellow dot is, then this field of view is what you can see. Of course, if you moved to another place on the Earth, then the stars you can see would change at any given time. Now, only north and south really matter here. East and west don't matter. Why? Because all of those stars will rotate past you. You'll get to see half of them in any given night, and all of them in any given year. So there really isn't any reason to worry about east and west here. Okay, in addition to the celestial equator, there's this other line called the ecliptic, and that is the line that the sun and moon travel as they go through the night sky. It's also the line that the other 5 visible planets, Mercury, Venus, Mars, Jupiter, and Saturn, largely confine themselves to, although they do not move constantly forward the way the sun and moon do, but rather circle in place. And they do dip above and below the ecliptic line a little bit as they go. Notice that it's slanted. Why is that? Well, obviously it's because Earth is slanted. Remember, Earth is not straight up and down with north and south on top of each other, but it's on a side at 23.5 degrees. So if you tip your head 23.5 degrees to the right, just like this, you'll see how Earth really is from the point of view of the sun. Okay, the ecliptic also tells us how the sun and moon and stars move through the night sky. They're in parallel to it. It also tells us where the 12 zodiac constellations are, which we'll get into later in the video. That was because certain superstitious people thought that, oh, whatever constellation the sun and moon moves through, oh, those must be pretty important, so we need to make a special term for those. Okay. So the slanting of this ecliptic means that this is what you're going to see if you look out into the night sky. Suppose you live in the northern hemisphere where my yellow dot is here, and you're looking south. Then this is what you'll see. The south will be right in front of you. The east, where the sun rises, will be to your left, and the west, where it sets, will be to your right. And the celestial equator will look like this because you're not right on the North Pole, you're kind of south to it, so you can see a little bit into the southern hemisphere down there. You can see a little below that equator. And then the ecliptic will cross through it in some way, depending what season of the year it is. So right here in the picture below, you can see we're in fall. And you can imagine yourself, if you turned around there where that yellow arrow is, you would see the ecliptic passing from the top left to the bottom right of your sky. But what happens in a different season? Well, this is what the ecliptic would do depending what season you're in when you look out. Because remember, you're not looking towards the sun. You're looking out away from the sun during night. You can only look out in a centrifugal, which means center-fleeing way. You can never look in a centripetal way. You have to wait till you get to the other side of the year before you can look in that other direction where the sun currently is. Okay, so that's what looking south looks like. Of course, if you lived in the southern hemisphere, then you'd switch it all, replacing all my norths and souths. And of course, during the night, the stars would move through the sky following the ecliptic. By the way, the white arrow here tells what direction the Earth turns. So notice how the stars move in the opposite direction. Because really, the only thing that's moving is Earth is moving. It only looks like the stars are moving past. Okay. And the same with the red ecliptic arrow down there. That tells you the direction in which the Earth moves around the solar system. And that means that as we're going along that route, it's going to look like we're seeing a section of the universe that is traveling in the opposite direction. So it's all about inverse directions of motion. Well, what about if you looked in the other direction, towards the pole? In this case, since we're imagining ourselves to be in the northern hemisphere, this would be the North Pole. What would you see then? Well, you would see your standard directions like that, but now all the stars would seem to rotate around a point in the sky. And in the northern hemisphere, there is a particular star that is right at the center of that, which is called the pole star, or Polaris, and it is the tip of the Little Dipper, which you'll see later in this video. So, going back to our schematic of the universe, I can't work with this round world here, so what I'm going to do is something you often see on maps. I'm going to pretend that this is a piece of dough, and I'm going to take my rolling pin and I'm going to smooth out the four corners so that it turns into a square. So here we go. We're going to distort it from a circular to a square layout. Watch this. And this is what it would look like now if you distorted the whole night sky into a square. And let's also pick up the part of the night sky that is behind us that we can't see because the sun is blocking it. So let's imaginatively pull that in too. And so now our sky is double wide, okay? Okay, this is what we're going to use to learn the constellations. So our ecliptic now is not just a gradual up, but it's now making a complete loop returning to the latitude of its starting point down low. See that? And our field of view is now much wider up at the pole because, of course, you can see all the way around the pole up there. And on this map, that pole is not just a point, but is the entire top of the page. Okay, so anyways, the Christian constellations.